Thank you for coming to Steamworks Features, a technical overview. Please welcome Chris Boyd from Valve.
Well, hello. That's bright. All right, so my name is Chris Boyd. I'm a developer on Steam, and I'm going to be covering some Steamworks features today. So this talk is really intended for developers who are new to Steam and really are getting started or haven't seen lots of features in the SDK. After this talk, there's going to be a breakout session in 611. So if you have any questions about this talk or just any features on Steam in general, there'll be a number of developers and myself there who have implemented most of these features and can answer all of your questions. Just to get started, I want to talk briefly about Steam. There's multiple sections in Steam, and I'm going to be covering really three parts: the Steam Store, the Steam community, and also the Steamworks SDK, which is basically a C++ library that you can use to implement most of these features. And also there's a set of tools in there as well to help you publish your game. So the Steam client and the SDK are all available on Windows, Mac, and Linux. The nice thing with this is when you write C++ code in the Steamworks SDK, that same code will work across all three platforms. In addition, most of the features I'm going to talk about have web versions. So if you have a backend system that would like to set achievements for a user or maybe get leaderboard results, you can make those requests from your servers to ours using HTTP requests. I want to start at the partner site. So this is a website where you'll do pretty much everything related to Steamworks. Once you log in and create an account, you can download the Steamworks SDK. And it's also where you'll go to edit Steamworks data. So when you build achievements or you want to manage your builds for your game, this is a site you'd use. We've also recently made it possible to edit store data through this site. So as you add promotional material for your game, such as screenshots and media and videos and other descriptions, you do that through the partner site. In addition to Steam Dev Days, there's quite a few ways to get help with Steam. So the first is on the partner site, there's a set of documentation that describes all the Steam features and also some best practices and tips. So that's a good place to start for documentation. In addition, the Steamworks SDK has a number of C++ headers which have pretty detailed documentation on each method. So as you're developing, it's a good place to just switch over to the Steam header, and then you can get a little bit more information about the functions you're calling. In the Steamworks SDK, we have an example app that is basically a little multiplayer app that we distribute the source code for. So this application integrates most of the features I'm going to talk about, and then some. So if you're looking for how to implement achievements, or maybe see how we've done lobbies or cloud storage, that's available in the source code. It's also a good place just to do some testing. So if you'd like to see how to make some changes to the lobby system we've done, it's a good place, a good application to experiment in. Lastly, if you've looked through the documentation and you're still looking for some information, there's a Steamworks developer group on the Steam community, which has a discussion forum that's frequented by both Valve employees and other Steam developers. It's a great place to go and ask questions, and people are really friendly there and can give you more information. As I said, this talk is going to cover a number of Steam features, but it's not going to cover the entire set. So if you have any questions, please feel free to find me or another Steam developer after this talk. And the Steamworks SDK is a collection of features that usually come from partner suggestions. And that's really what drives how we decide to build features and put in the SDK. So if you have a feature that you think is appropriate for the SDK, whether it's just exposing a little bit of data, or maybe it's a whole feature, please feel free to send it to one of your Valve contacts or post it on the discussion forums, and we're more than happy to look at those and and integrate those into the SDK. So I wanted to spend some time talking about how you build a game with Steam, and then the process from development all the way through release. All right, so at Valve, how we really rely on Steam during the development process. So the standard procedure for a game is once we've started work on a game, we'll take the content for that game and we'll upload it to Steam. Regularly, developers working on that game will check source control and determine if the build is stable. And if it is, they'll take those bits, update the version on Steam, and then send an email to the rest of the company saying, hey, by the way, there's a new version of the game that's available, please play test. And so this is great for us because it allows us, or any employee at Steam, whether they work in the main office in Seattle or somewhere else in the world, or they're on that game team or on another project, anyone in the company can fire up Steam, get the build from most likely yesterday, play test, and then submit feedback. So this really helps us solve during development how to distribute builds around the company, and then also make sure that everybody's using the latest build. So before we get into how to do this on Steam, I want to talk about access to the development builds. So there's two ways that you can that a user can gain access to a dev build. The first is on the partner site, there are publisher groups which every publisher and developer is part of. Those groups are associated with games, and any user in those groups can download the development build. Now, this is really nice because it lets your administrators control who has access and see and either add or remove or just audit who's currently downloading your development builds. In addition, we also have CD keys which can be marked for development, and these are usually used for external tests. So for example, as you get close to release, maybe you want to send your build out to some press or some other testers, this is when you'd use CD keys. Now let's talk about how to get a game on Steam. So in Steam, we have what we call depots, and a depot is really just a collection of files. You can think of it as a zip file that has both encryption, the content is compressed, but depots are also versioned. So what we recommend is when you sign up for Steam, take all of your content, create a depot, and then throw it up on Steam. This will let anybody in your company download and test the current build. As you work through development, there'll become a point where you realize that there's other types of content which maybe all users don't have to download. An example of this is usually localized content, or maybe it's OS-specific content. So for me, for example, when I play, I might be playing on SteamOS in English, and I really need all the game's content and just the English files. I don't need French, Spanish, etc. So Steam has, once you have that initial depot, you can create new depots that break out this content for users. This is something you can do after you start development, and as you work through development, kind of fine-tune where content goes in what depots. Now, there's going to come a point in time where, as you're on Steam, you're going to want to have multiple versions of your game. And this could be, you may have a QA build, you may have a nightly build, you may even have a press build, for example. So the way Steam does this is with branches. So as a depot is simply a collection of files, a branch really just points to a depot and its specific version. So for users, when they go to download your game, everyone gets the default branch, and this is a branch that exists for all games on Steam. When you make new branches, users can opt into those branches. So for example, your QA department can opt into a QA branch, you can password protect that optionally, and then from then on, any QA builds will go straight to them. Now, the nice thing with branches is, as you're developing, that default branch is going to become the content that is released to users. So with this system, not only are you using it internally to test, but it's also, you're using the same environment that users will eventually use on Steam. So as you're developing, you're also going to think a little bit about retail channels. So on Steam, when a user buys a game, we simply just add ownership to their account. However, it's obviously very common to sell through other retail and digital distribution channels. So for this, Steam can create CD keys for you that those channels can give to users, and once a user has a key, they simply enter that into Steam and then gain access. In addition, when you sell at retail, you're probably going to want to make a CD that's included in a box, and then that's sold through that channel. Steam has a set of Golden Master tools that result in a setup executable that is usually auto-run when you pop the disk into the machine. Now, the nice thing about this setup executable is that once it runs, the first thing it does is installs Steam, and then the rest of the installation process is completely updatable. So, and it's happened before, and I'm sure it'll happen again, is somebody will make a gold master and you'll just accidentally forget something that's really critical. Maybe you forget DirectX or some other required runtime. So with Steam, once that update has been applied to Steam, During installation, that problem can be corrected, and users will, who install after that point won't run into any issues. One thing to remember when making a retail CD is that the default branch is what's used to put content on that disk. So when you make a retail CD, you want to do it a little late in the development process. And the reason is because you want that disk to match your day zero update as closely as possible to just reduce the amount of content users have to download when they purchase your game. Now, your game's out, things are going great, and it's time to do some updates. So at Valve, we're really big on updates, and we've tried to lower the bar for any of our partners doing updates as well. For this, we handle all of bandwidth costs, and there's also no certification. So what that means is there's no barrier and no one at Valve who's standing between you guys publishing an update to your users. So as an example of this, I'm going to use Team Fortress 2. So when we made the TF2 beta and released it early on, I think it was under 60 minutes into release, we had to do an update because we realized there was some catastrophic failure that was blocking users from playing. So we really quick scrambled, made a new build, pushed that update, and then all future users didn't encounter that issue. And so the nice thing with this is every time we fix a game, it both lowers the pain point for users and also it removes any support calls. We're also very fond of doing updates, and TF2 is another good example where after that first real quick update, we've updated it more than 400 times. So these are both quick fixes, and these are also big content updates. And we rely on this quite a bit to give new content to our users, and it really extends the lifetime of the game. One thing to remember with Steam is that as you do development, you're simply updating these depots that we originally talked about and created. The Steam itself will only download what is changed in a depot. So if you have a really large file, which is fairly common in game development, only the bits in that depot that have changed, or that file that have changed, are what Steam will download for users. Lastly, I wanted to talk really bit about error reporting, or really quick about error reporting. So after your game is released, you're most likely checking discussion forums and customer service calls, et cetera, just to determine what issues users are running into. To help find crashes in games, we've actually added a crash reporting system to Steam. And this is only a few lines of code, and it's available in the Space4 SDK. Feel free to copy those lines into your application. And the way it works is when a game crashes, a mini dump is generated. Steam then collects those mini dumps and then uploads them to the partner site. And then on the partner site, some analysis is done. Those dumps are aggregated into buckets, so you can see if how many users are hitting a particular crash. And then you can download that dump and get a call stack and then fix the issue. So next I want to talk about the community section on Steam. And the community itself or the community section is obviously very popular with users. It's a place where users will have their own profile, they have their friends list, and they can see what else is going on in Steam. They can see what games their users are playing, what content is being generated, etc. So what we find is that one of the best ways for people to market a game is really marketing to your friends. So when I see a friend on Steam playing a new game that I don't know about, I'm usually much more likely to go look at the Steam store page and look at reviews and things like that for that game to determine if I should purchase it. The community features I'm going to talk about give users a really easy way to broadcast out to their friends what they're playing and show what they really like about a game. So first we'll cover achievements. Achievements are pretty much like match what you've experienced on other platforms. In a game, there's a specific goal. Once the user accomplishes that goal, they gain an achievement. On Steam, achievements are very lightweight and easy to implement. You simply need an image for the achievement not being achieved, one of when it's achieved, and a simple call in your game through the C++ library to say, grant this achievement to a user. And once the game makes that call, Steam does a couple different things. First, a little notification pops up that says, hey, by the way, congratulations, you've achieved this achievement. And second, that data is pushed to the Steam community. So on the Steam community, I can see a list of all of my friends and what they've been doing on Steam. And part of that list is all of the achievements that my friends have gotten this week or this month or whatever time period I'm looking at. In addition, the achievement can also be featured on the user's profile page. So users can create an achievement showcase, as shown here, and you can put, the users can put the achievements that they're really proud of and they care most about in that showcase. Now, Steam also has a stats system, and that's used closely with achievements. The stats system is basically just arbitrary integer values that a game chooses to set for a user. And the way this is used with achievements are, imagine you have an achievement that is, say, after 10 multiplayer wins, you unlock this particular achievement. So user stats and achievements are both stored on the user's account in the cloud, and every time a user plays your game from wherever they play from, if they win a multiplayer match, you can increment the wins stat, and then simply once they get to 10, you can unlock the achievement. In addition, we also have leaderboards on Steam, and these are basically just a ordered list of users by some game-defined score. And an easy example of this is if you're a racing game, for example, maybe you create a leaderboard to store the best times the user has on a particular track. Or maybe you're an arcade title and it's just the highest score on a particular level for your game. Leaderboards are, again, stored in the cloud, and there's a couple nice features with them. Each entry can have data associated with it that is not just that individual score. So for example, maybe my racing game has the lowest number of seconds as the top person on a leaderboard. You can also associate with that entry what car the user was driving, what friends he was playing with, maybe like the tuning settings of the car, etc. It's all game-defined data that the game can retrieve when displaying that leaderboard entry and give other users kind of a view into what the user was doing and how they set that score. In addition, leaderboards can be created dynamically, and this is useful for, say, your game has a mod system or maybe custom maps. And as users create those maps and then they upload them for other users to enjoy, your game can also dynamically create leaderboards for those levels so that they're as a rich and a nice experience as a first-party level. Now, it's important to remember that leaderboards and achievements can have their content can be accessed through HTTP web requests. So if you have a backend system that or a backend server that generates maybe a web page that users can log into, you can request this data and other community data about a user and then use that data on your site as well. So maybe I log into the game's site and it has a much richer view of leaderboards and achievement data, also shows my friends and other types of features. Now I want to change and talk about trading cards really quick. This is a new feature that's been added to Steam, relatively new. And it's something that the community really has enjoyed. And so much so, we have some people at Valve who are just addicted to getting any trading card they can find. So trading cards themselves are associated with a game. Games will usually have 6 to 8 of them. And how they're built is you upload some really nice high-res artwork about the game. Steam adds the border to it, and then as users play your game, Steam automatically gives out some subset of the available trading cards for your game. So this is important that users are simply playing your game and having fun, and then on the side, they're getting cards. There's no grinding associated with it or hoops that they have to jump through. After a game has given out a certain number of cards, users can choose to collect the rest of the cards in your game set. And they can do this by a couple methods. One is simply just trading these cards with friends, and the other is purchasing cards through the Steam marketplace. Now, once a user has all the cards for a game, they can craft those into some rewards. Now, there's 3 things that you get. When you craft trading cards, you first get a badge. And this is a nice little icon that you can display on your profile page, and it also increases your Steam level. And the cool thing with this badge is my friend Alden here has in the top right, and he's a big Meat Boy fan, and I can identify that just by going to his profile page. There's also profile backgrounds, so a user will get one of those as well. And again, looking at Alden's page, he also really likes TF2, and his page is decorated with these really nice TF2 turrets. And lastly, users get an emoticon. And you can think of this as a small icon that can be used in various places around Steam, mostly with chat. So when I'm talking to one of my friends, I can use the emoticon in chat there. I can also use it in discussion forums, and I can use it when posting on profile pages. So the nice thing with all of these is that as I'm browsing through Steam as a user, there's been many times where I've seen a really cool emoticon used, and I just mouse over that, and I want to know what game it's from. First, it tells me that my friend has done, really liked this game, and they did the work to get that emoticon. But in addition, it also gives me the opportunity to learn more about that game. And there's been plenty of times where users have seen an emoticon, and then they go to the Steam store to find out more. I briefly wanted to talk about guides. Guides on Steam are created by users through the community site. You can think of a guide simply as a wiki page that has text, video, and screenshots. Now, guides can be about anything users would like to talk about. It could be how to play a hero in a particular game, or maybe it's a full walkthrough. But the nice thing about guides is they are just user-generated content. So your game can access this content through the Steamworks SDK. We're hoping to see games come out in the future that do a nice job of integrating guides. And an example of this could be maybe my game has a very difficult level, and after the user has failed a couple times, maybe the game could give a helpful suggestion that says, hey, by the way, we see you're having some trouble. Would you like to look at some suggestions from users on this particular level? In addition, the Steam community also has user-generated screenshots. So the Steam client itself can take a screenshot, and once the user opts to take a screenshot, at the end of their gameplay session, the client gives them the opportunity to upload that to their profile in the community and also share that screenshot with all users in the community. Now, there's a couple problems with Steam taking the screenshot. First, you're in the middle of a game, and there's the HUD is displayed, and maybe I'm trying to shoot a guy in the head, and I can't hit the screenshot key and shoot him at the same time. So what we've done is we've added a screenshot API, and that API allows you to do a couple things. First, you can tag users who are in the screenshot, and you can also tag the location of where the screenshot was taken in your game. Second, we've also given the ability to add a screenshot for the game to take the screenshot and then add it to the collection of screenshots for the user. And this would be nice for both removing that HUD I was talking about, but also just taking pictures at really cool times during the game. So the game knows when I set a high score, they know when my nemesis kills me, and it gives me a good, it gives the game a good opportunity to generate a screenshot that both the user will enjoy and then also their friends in the community will enjoy as well. Next, I want to transition to talking about selling content on Steam. So we talked about the dev cycle for bits, where you start in development and you go all the way through release. And I want to talk about how that works on the Steam store. So on the Steam store, every game has their own game page. And that game page can be edited through the partner site. And on this page, you're going to put trailers, videos, descriptions, and other marketing material for your game. As you get close to release, it's important to start thinking about when to put up a coming soon page. So when you have a time for when you expect your game to release, it's usually a good idea to create your Steam page and take any marketing materials you have and put it on that page. Now, this page will actually change over time as you get close to release. So you start it at a coming soon page, and then if you enter early access, it'll change into your early access page. And then once you get closer to release, it will just change into the standard page on Steam where your content is sold. It's important to remember that when you're developing your game, to continually update this page, as this is a place in Steam where users will go to get more information about your game as you develop. So after your game is released, there are two different ways to sell additional content. The first we'll talk about is downloadable content. And this is content that is sold through the Steam store. This content, there's usually a downloadable component to this, and each piece of downloadable content will have its own depot. So once a user purchases your game, they'll simply download the additional content, or the Steam client will simply download that content. Downloadable content itself is usually used for things such as expansions and maps. You can also use it to do simple access checks, such as if in a real-time strategy game, if you have some units in the game that are can only be controlled by after a purchase, you can use downloadable content to buy access to those units. One thing to remember with downloadable content is that Steam itself does do the download for all of that content. And you would update that content just like you would update other content for your game. In addition to downloadable content, we also have microtransactions. So the difference between microtransactions are that they are actually sold in a store that resides in your game, where downloadable content is sold through the Steam store. Microtransactions are also content that is defined by the game and can really be anything. You could have downloadable content for hats, you can have it for coins, you could have it for experience boosts, or other time-limited types of features. So the way microtransactions are implemented are the game creates and runs its own server that manages both items, and it also manages initiating purchases for microtransactions. And as a user, when I go into a game and I select purchase an item, the game itself will talk to its own server. Then that will talk to the Steam backend and say, please debit the user's wallet for the following amount. Now, microtransaction prices are actually set by the game at the time of purchase. So, and this is also done in the user's local currency. So for me, it would be in USD, but you can also purchase in any other Steam currency, such as pounds, euros, and rubles. Once the user has funded their wallet and the purchase is complete, Steam will then respond to your game server saying that the user has been charged, and the game can then allocate items for that user, and then the user can use those and proceed. It's nice to note, too, that we've designed the UI for microtransactions to be very lightweight. It's an in-game type of purchase. So if you have a moment in-game where the user needs to make a really quick purchase, that is another thing microtransactions can be used for. Once you've implemented a server for doing microtransactions, it's very easy to also implement or add support for both the Steam community and trading through Steam. Now, both of these have already been talked about today, and there are videos that will be made available on that. But in a nutshell, on the community, all you need to do is add support for the Steam Econ API, which is a simple API that lets Steam retrieve the user's backpack and what items are in it, and also to tell that server to conduct a trade. Another closely related feature is the Steam Workshop, which again was also talked about today. And just remember that the workshop is good in that curation model to allow users to submit items that can then be sold as through microtransactions within your game. The last set of features I'd like to talk about today are matchmaking through Steam. Now, this is basically how a user finds a multiplayer session in your game. Traditionally, in PC games, users have started up a game and they've used a game server approach. So I click in TF2, for example, there's a button I can click for multiplayer that will then bring up a server browser, and it sends a whole lot of servers to me, and then my client pings those servers, determines what map and how many users are on them, and then the user would have to filter through these servers and then select a particular server. Now, Steam has a game server API in it, and if it's appropriate for your game, please feel free to use it. Most games have changed to a more automatic matching approach, and for these, it's more appropriate to use lobbies in Steam. Now, a lobby in Steam is simply, you can think of it as a really beefed up chat room. So it's a number of users can join a lobby, and then you can set game-specific data on that lobby. Once that data is set, other users can query for that data and then join the lobby and start a multiplayer session. Now, I'm going to go through an example of how Left 4 Dead uses this. But please remember that lobbies and any matchmaking process is really game-specific, and the point of this is to give you some ideas of how you can use lobbies, and then once you've determined, or how you can use features in Steam to really build the optimal experience in your game. So in Left 4 Dead, when a user clicks play a multiplayer session, the game itself behind the scenes creates a lobby. The person who clicked play or play multiplayer is made the owner of that lobby, and they can set different game settings on the lobby. For example, they can set the difficulty setting, and they can also set what map they'd like to play. In addition, the owner also needs to choose who they'd like to play with. And so they can set three other settings on the lobby. They can mark it as private, which means they would have to invite anyone into the lobby to play. They can set it as friends only, and that would mean that they could still invite people, but also any of their friends could automatically join the lobby. And then they can set it to public, which means just anyone who wants to play Left 4 Dead can join the lobby. Now, once the user has made these decisions and created the lobby, another user, such as myself, can go search for a lobby. So I would search for a beginning difficulty lobby and someone who wants to play on the first map in Left 4 Dead. Once I find a lobby that matches those settings, I would join the lobby, and then I could also set data about myself in that lobby that pertain to the multiplayer session. So, for example, in Left 4 Dead, when I join a lobby, I set what character I'd like to play. Once the lobby is full in Left 4 Dead, the user chooses to start a multiplayer session, and then behind the scenes, a multiplayer session is created, and all of the users in the lobby go join that session. But it's important to remember that lobbies themselves are really lightweight objects. So in Left 4 Dead's case, there's 4 players are allowed to play at once. However, if one of those users drops out, another user can join the game midway through. So the way Left 4 Dead implements this is it has a lobby that's created before the game starts. That lobby's left open for the entire game session, and if a user joins midway through the game, the user simply retrieves the multiplayer session data, which is usually an IP import from the lobby, and then joins that server. As I said, lobbies are very lightweight, and they also can be used for many different purposes. So I've talked about here how Left 4 Dead uses a lobby to simply represent a game session. But you can also create lobbies to represent chat rooms or even party systems. Users can be in multiple lobbies, so users could join a party and a chat room and then still also join a multiplayer game. Another thing to consider about lobbies is that there's no UI associated with the API. It's simply a set of back-end calls that manage users and distribute data. So when you're building your multiplayer matchmaking, remember that you can set the UI. So say, for example, or in this example, Left 4 Dead has 4 users in a lobby with a bunch of different settings, but maybe you're at a real-time strategy game that just wants to pair users to do head-to-head play. In that case, the UI could be as simple as a spinner and a please wait while we find a user label. And behind the scenes, the game can create a single lobby and have another user join it, and then the game just automatically starts. When people use lobbies, we get a number of frequent questions, and I wanted to cover the top 3. So when users are playing multiplayer games, there could be lots of lobbies that match the user's search criteria. And in that case, when the results are retrieved, say there's 2,000 results that matched and the game only won the top 10, those top 10 will already be sorted geographically. So that means that as far as Steam can tell, it should be the best, the lowest latency connection for that user to the owner of the lobby. Second, lobbies can also be used with skill-based matchmaking. So I'm not going to go into the full details here, and there's a document on the partner site that discusses how to do skill-based matchmaking with lobbies and stats in Steam. But as a really high level, the game simply generates a number that represents my skill level. So maybe that's 500. And then when I create a lobby, it sets that value in the lobby data. Other users can then search for a range, say 450 to 550 of skill, find my lobby, and then we can play a game with reasonably matched skills. And the last thing I want to talk about are lobby search results are really quick. It takes like 200 milliseconds to issue the request, hit the Steam servers, and come back again. So what this means is that when you make a search, feel free to make that search as very restricted or restrictive or fine-grained. And then if no results are returned, relax those search results and search again. Now, as you're building your multiplayer, once users have joined a lobby or a game server, there's going to come to a point where you're going to, if you're doing peer-to-peer games, that you're going to need to send traffic between clients. And for this, Steam has a peer-to-peer networking layer which handles NAT traversal and makes it really easy to connect users behind home firewalls. The library is appropriate for sending reliable data, such as game-specific data, and for the multiplayer session. And it's also appropriate for sending unreliable data, such as if you have voice traffic inside your game. We've tried to make this API very easy to use, and so instead of requiring dealing with IPs and ports and binding to sockets and listening on sockets, Steam simply requires you to build the network message you want to send, and then the call routes it to a specific Steam user. So Steam handles under the hood all of the networking for you, and if the two users happen to be in a very rare situation where the Steam cannot make a direct connection between them, most likely through some specialized home networking equipment, the Steam will route that message through the Steam backend, and it guarantees that the networking message always gets between two users. The last thing I want to talk about really quick is rich presence, which is a fairly new API that we've added to Steam. I'm going to go through an example of how Dota uses it, but we're also interested to see how other games will leverage it as well. So rich presence is simply just a collection of, like basically a dictionary on the back end of user data when they're in a game. And I'm going to use the example of Dota here, and this is an in-game Dota friends list. So when I join a game in Dota, Dota sets some rich presence data about me. Either I'm looking at the main menu, or I'm spectating a game, or if I'm in a game, it also sets what hero I'm playing and what level I am currently at. This is obviously a nice way for Dota to easily send more information about my multiplayer session to all of my friends, and then they can get a quick view into what I'm doing. That's the end of this talk. I think we finished about 5 minutes early. Thank you for coming. There's a breakout session in 611. If you have any questions, please come to that. And then also, myself and some other Steam devs will be down at the front of the stage here to answer any questions you have before then. Thank you.